What are convex and concave polygons and what is the difference between the two? Here we have some figures, and on the next slide we have some figures. Let's start from this one. This is a quadrilateral because it is a four-sided polygon. If I take a pair of points, let's say this point and this point, so we have a pair of points. If I connect these 2 points, then tell me, is this line segment that is joining 2 points, where 2 points lie within the boundary of this quadrilateral, is this line segment completely within the boundary of quadrilateral? Yes, this line segment is completely within this quadrilateral, within the boundary of this quadrilateral. Let's take another pair of points. Let's say I take here and I take here. Okay, so if I connect this, now tell me whether this line segment joining 2 points such that the points are within the boundary of quadrilateral, then tell me, is this line segment within the boundary of quadrilateral or not? Yes, it is completely within the boundary of this quadrilateral. But if I take this figure, let's say, okay, or even this one, here if I take this point and this point, and if I connect it, so 2 points that are within the boundary of this quadrilateral, if we connect it, the line segment, is this line segment within the boundary of the quadrilateral? Yes, it is completely within the boundary of this quadrilateral. But let's say I take 1 point here and 1 point here. Now if I try to connect this, now tell me, here again we have taken 2 points. 2 points lie within the boundary of this quadrilateral or any polygon. In this case it is quadrilateral, but let's say any polygon. If such condition comes where you take 2 points within the boundary of the polygon, but the line segment that joins those 2 points lies outside, if even a slightest portion of that line segment is outside the boundary of the polygon, that is, if that lies to the exterior of the polygon, then that is a concave polygon. This is a concave polygon because here this portion of line segment is to the exterior region of this polygon. So this is concave and this one is convex. Doesn't matter where you take 2 points, whether at this end and at this end, if you connect, the line segment connecting those 2 points will lie completely within the boundary of the polygon. That is why this is convex. Convex and concave. Like here I show you again, if I take, let's say if I take this point and this point, here you can see if we connect this, the 2 points are within the boundary of this polygon, that is 1 2 3 4 5 6. It means it is a hexagon. It has 6 sides. So 6-sided polygon has 2 points within the boundary of the polygon, but the line segment that joins them, it has its some portion outside to the exterior region of this polygon. Same thing here. If we connect this point and this point, it's something like this. If you take this point and this point, let's say here, again this one, these are all concave polygons. In these figures, if you take any 2 points which are within the boundary of this polygon, then all of them will actually, if you connect them, then all of them are actually within the boundary of this polygon. Okay, therefore all these figures are convex polygons. One more important thing, these were the 2 points. In this case, can you tell me that whether, if I name these vertices A, B, this is C and D, now tell me whether the vertex D and vertex B, are these non-consecutive vertices or not? Yes, they are non-consecutive vertices. So if I join these 2 non-consecutive vertices, then tell me, isn't the line segment BD or DB, isn't it a diagonal, right? Diagonal BD or DB, yes, they are diagonal because they are connecting two non-consecutive vertices of this polygon or quadrilateral. So if your diagonal is outside the bound, lies outside the boundary of a polygon, even in that case that is a concave polygon, right? Similarly here, if you name all the vertices here, this is A, B, C, this is D, this is E, this is F. If I take vertex E and vertex C, this vertex C and this vertex E, these are non-consecutive vertices, and we have learned that whenever we connect two non-consecutive vertices, we get what? Diagonal. So if I connect this one, then tell me, isn't it a diagonal of this particular hexagon? Yes, it is. The line segment CE or line segment EC is a diagonal, and this diagonal actually lies outside this polygon. Whereas if you connect these two non-consecutive vertices, you can see here, if you connect these two non-consecutive vertices, this diagonal lies within the boundary of this of this polygon. But we cannot say that it is a convex because one of its diagonal is outside of this polygon. Therefore, if you similarly here, if you want to connect it, let's connect this one. Two non-consecutive vertices, a diagonal which lies outside the boundary of this polygon, it is a concave polygon. Same thing here. Right? Concave polygon. But in this case, if you connect any of two pairs of non-consecutive vertices here, if you connect this one and this one, completely lies within the boundary of this polygon. If you connect two pairs of non-consecutive vertices in this case, completely within, right? If you want to check for this one, let's do it. This, like this. So these are all possible diagonals of this pentagon, and clearly all diagonals are within the boundary of this pentagon or polygon. So all these are convex polygons.